All right, so this is you're going to be learning about acceleration. The goal here is to understand what is acceleration, how's it different from velocity, how do we do acceleration calculations. But before doing that, I want you to work through this list of math problems to see if you can solve or see what the answer is. This will help you understand units that are applied in the calculations we'll be using. So go ahead and pause now and see if you can figure out the answers to these 8 math problems. So 1/2 times 2 is 1. 1/seconds divided by seconds is 1. Meters per second times seconds, the seconds cancel out and we have just meters. Meters per second times meters per second gives us meters squared over seconds squared. All right, and here are the answers for the others. That last one's pretty tricky, but it's something that we'll see. Okay, so performance. What does, this is a picture of my car, by the way, sitting in my very spacious garage, and it goes from 0 to 60 in 3.2 seconds. What exactly does that mean? Or if I had 0 to 100 miles per hour, 7.9 seconds, what does that mean? Those are accelerations. An acceleration is how your velocity changes divided by the time it takes to change. So in math terms, it's average acceleration is equal to delta v over delta t. And because the initial time is most of the time going to be 0, we would just write that normally as delta v over t. And it has these very strange units of meters per second squared. Can we have a negative acceleration? What do you think? Yes, of course we can. If our final velocity is smaller than our initial velocity, if that number is smaller than that one, then you would have a negative acceleration, totally allowed. This entire year we're going to study 2 types of motion. One is constant velocity, where the displacement is changing at a constant rate, and the other is constant acceleration, where velocity is changing at a constant rate. So the good news is, though we are studying all different types of motion and applying these concepts, the only 2 that you really have to know inside and out are constant velocity and constant acceleration. So here are the equations of motion. This is just so you understand what delta means, so change in position. This is constant velocity, the constant velocity equation, and the constant acceleration equation. And again, remember, you can pause this video anytime you want, so you can write this stuff down. All right, so again, here's my car, the CCR. Nice car, not very good on mileage. The tires cost a fortune, but you know what? It's worth it. Because I can go from 0 to 100 miles per hour in 7.9 seconds. And you know, when I need to get to school and I'm running a little late, that's pretty helpful. So we are going to calculate the acceleration in meters per second per second. I set up my my variables. 0 is my initial speed. My final speed is 44.7 meters per second, or my final velocity. I converted that from miles per hour into meters per second for you, and in a time of 7.9 seconds. My formula, acceleration, delta v over delta t. Then here's the work. My change in velocity divided by the time. So the acceleration is a blazing 5.67 meters per second squared. What about if I see a traffic jam ahead and the car needs to slow down from 29 meters per second to 12 meters per second, 65 to 27 miles per hour, and I do that in 3 seconds? What is the acceleration in this case? Well, my initial velocity, 29, final velocity, 12, in a time of 3 seconds. The acceleration is delta v over delta t. I plug in my numbers, 12 minus 29 divided by 3. Negative 17 divided by 4, giving me a negative acceleration of 5.7 meters per second squared. So, using acceleration of 6 meters per second, fill in this table. Now, what exactly does that mean? We can say 6 meters per second squared, or we can say 6 meters per second every second. That's what this means. That's what acceleration means. It means how quickly is that velocity changing per second. So I'll give you the answer to the first one. After 1 second, if it's changing at 6 meters per second every second, that means after 1 second, it's traveling 6 meters per second. Pause now and see if you can figure out how fast it's going after 2, 3, 5, and 10 seconds. All right, so hopefully you pause and work through this. Here are the answers. After 2 seconds, you'll be traveling at 12 meters per second. After 3 seconds, 18. Why? Because every second, the speed is increasing by 6 meters per second. 5 seconds, 30, 10 seconds, 60 meters per second. 60 meters per second, by the way, is about 120, 130 miles an hour. Pretty good. All right, so my scooter, not quite as fast as my CCR, but has an acceleration of 1.2 meters per second every second, or meters per second squared. Starting from rest, how fast am I going after 8 seconds? So I write down the things that I know that I'm looking for, my formulas. This time I rearrange the formula, so it's delta V equals A times T. Do the work. So, looking at this problem, pause now, work through it, see if you can come up with a solution. I'll wait as long as you need. Okay, so hopefully you've worked through the solution. It's really pretty simple, 1.2 times 8. This second cancels out the squared on the bottom, so we're left with just meters per second, which makes sense because we're looking to calculate a velocity. All right, here are some various accelerations. So pause now, give this list a gander to get an idea of different accelerations. The getting out of bed, if you're a high school student, it might be more like this. But, for the rest of us, it's somewhere around 2 centimeters per second every second. All right, can we have a negative velocity? Yes, we can have a negative velocity. Can we have a negative acceleration? Yes, we can have a negative acceleration. If a car goes from 20 to 10 meters per second, is the acceleration positive or negative? Negative, of course. Car goes from 20 to 0, is the acceleration positive or negative? Still negative. Good. If a car has a velocity of minus 20, does that mean it's going backwards? No, it just means it's going in the negative direction. And that's it. All right, so hopefully this prepares you for the worksheet that you're going to get in class tomorrow. And we'll see you.